Okay, so what I'm going to do is I'm going to show you, anybody was absent today, show you how to go through this process of doing this. And I've got my iPad up there and also the assignment. So we'll be going back and forth between this and my iPad, which is there. So first of all, let's look at this. This is what we're doing here. We're looking at this one right here. This is a 1 kilogram weight. This is my effort. So this is the resistance. This is the effort. I come down here and I go, oh, wait a second. I need to... So I open up this here. This is that it? No. Yeah, that's it there. That's the on-shape one. So I come over to on-shape, which is right here. And the way it's set up for you guys when you first open it up is here. I have to click on this button right here. Okay, this is turned off. So I'm going to click on here to figure out. Now, the first thing I'm going to figure out is I'm going to figure out the resistance distance. So I go from the fulcrum to the center of the resistance, right there. And I get 7.5, basically 7.5. So let me go to here, go to my iPad here. I'm going to write that down, 7.5, and that's my distance from my resistance, which is down here. Distance from my resistance is right here, 7.5. 7.5 inches, okay? Then I come over here, I click down here, I come back here to the center, come over to the second one from the far side there, and I get 3.72. So the distance for the effort is 3.72 inches. Okay? I know the force for the resistance is 1 kilogram or 1,000 grams. Okay? Once I've got that, I can start working on my IMA. Okay? You can't see it. Let me go back to, there we go. Move over here, so let me move it back over here. Hold on. There it is right there. Okay? Okay, so I've got my information written down there. 1 kilo. I don't know the force of the effort yet. I don't know that. I'll figure that out shortly. So what I have to do is the distance of the effort. Distance of the effort is 3.72 divided by 7.5. Take my calculator out. 3.72 divided by 7.5. And I get 0.496, or we'll just say 0.5, around 0.5 is my IMA, okay? The next step then is to come down here, and we've got to figure out this here, the force of the effort force right now. So I've got to come down here and go, so the force of my effort, I don't know yet. So force of the effort is my unknown. Then my distance of my effort is 3.72. And then I get inches, that's inches. And then the force of the resistance is 1 kilogram. Times the distance of the resistance is 7.5 inches. Now, in this case, I want to try to change, I'm going to change all my, convert everything to centimeters, and then also to grams. I want it to be the same. I'm sorry, I've got it, so it's the same units, right? So let me go to my convert. I have a convert thing on my phone. You can use that all you want. So let me go to convert here, and I type in 3.72. Which gives me 9 points, so force of the effort, force is 9.5 centimeters, equals, we're going to go 1,000 grams, times, so let me change this to 7.5 here, and I get 19, so it's going to be 19.05, or it's 19.1 centimeters, okay? Okay, so now I take my calculator out. I'm going to divide both sides by 9.5 to get my force, my effort force. And so it's going to be 1,000. Let me do that here in my calculator. 1,000 times 19.1. Oops. 1,000 times 19.1. Which is 19, and then divide that by 9.5. Which gives me 2011, okay, grams. So that's going to be 2.0 kilograms. Okay, so that's what I'm assuming. This is 2.0, so basically 2 kilograms. So it's going to take twice the effort, which basically tells me what this is right here, because remember, it's half of 1, so it tells me it's going to be about twice the effort. So now my next step is to figure out my AMA. Okay, my AMA is going to be the force of the resistance divided by the force of the effort. So to do that, I have to come down here to this, right there, this thing right here. Okay, so I got to double click on that, show that. There we go. And I'm going to fast forward it here to where I want it, because that's what I want right there. This is the actual force that I've got. The actual force that it came up with is actually, this is what we're assuming it is. I'm sorry, I shouldn't have written that there. It's going to be 24.2 newtons. 20 newtons, okay? So let me bring my close out of that. Bring this back up. So I got rid of that because that's just what we're predicting it would be, okay? So we got 24.2 newtons here. Now we got to change newtons to kilograms, right? I can change it to kilograms right now. So let me go back to my my converter here and change it to, we've got newtons to kilograms, and I come over kilograms of force, and I type in, what was it? It was 24.2, which gives me 2.5 kilograms. So my force of my resistance is what? Is 1 kilogram divided by 2.5 kilograms. Gets rid of my units, and I go to my calculator, and I get 1 divided by 2.5, which gives me 0.4. 0.4 is my actual mechanical advantage, 0.4. And then for efficiency, I'm going to go to, I already have it written down here for us, so I know the efficiency is right here. The AMA is 0.4 divided by 0.5, which gives me 0.4 divided by 0.5, gives me times 100, which gives me, so I do that times 100, which gives me 80%. So it's 80% efficient. Okay, and that's how we do this. I hope that helps.